You think you know volcanoes, lava, ash, destruction. But what if a volcano erupts water? What if it shoots plumes 500 kilometers into space? What if it sits 22 kilometers high and covers an area larger than France? What if volcanism exists on worlds we barely understand, powered by forces that would crush Earth? Space holds volcano types that break every rule we thought existed. Ice that acts like rock. Nitrogen geysers shooting through frozen crust, shield volcanoes taller than anything on our planet, and the most volcanically active body in the entire solar system. Which worlds host these extremes? What makes them erupt? And what can they teach us about the violent forces shaping our cosmic neighborhood? Voyager. One takes images for optical navigation. Linda Morabito, imaging scientist, spots something strange. A cloud extending 300 kilometers beyond Io's limb. No moon should be there. She digs deeper. 8 volcanic plumes, all active, all erupting. First confirmed volcanism beyond Earth. Also, comment from which city you're hearing this from. This script is researched and factual, using sources from NASA's Jet Propulsion Laboratory, January 28, 2025, publication on Juno's most recent Io observations published in Nature on December 12, 2024, confirming individual magma chambers, and the comprehensive Voyager mission data archived by the United States Geological Survey from 1979. These sources detail the discovery timeline, thermal measurements, and magma chamber structures with spacecraft data spanning 4 decades. Now back to the information. Europa and Ganymede, neighboring moons, pull differently. Io's orbit becomes eccentric. Distance to Jupiter changes constantly. Closer approach, Jupiter squeezes. Farther orbit, Jupiter releases. This happens every single orbit, 42.5 hours. The squeezing generates friction. Friction generates heat, tidal heating, not radioactive decay, not primordial warmth, pure mechanical grinding of Io's interior. Galileo spacecraft arrives 1995. 8 years studying Jupiter's system. 6 Io flybys. Infrared cameras detect thermal emission, not just from plumes, from cooling lava on the surface. 100 times Earth's volcanic activity. Multiple lava lakes visible from orbit. Shield volcanoes, calderas, lava flows, all mapped. Closest approach in 2 decades. GIRIM instrument, Jovian infrared auroral mapper, Italian Space Agency contribution, designed to peer through Jupiter's clouds. Now turned toward Io, December 27th, 2024. Different flyby, farther away, 46,200 miles. GIRIM detects something unprecedented. 100,000 square kilometers, 5 times larger than Loki Patera, previous record holder. Thermal radiation saturates the detector, too bright, too hot. Alessandro Mura from National Institute for Astrophysics in Rome reviews data. Not one vent, multiple closely spaced hotspots, erupting simultaneously. Subsurface magma chamber system, vast, connected. Power output exceeds 80 trillion watts. 6 times all Earth power plants combined. Rich in sulfur dioxide. The eruption reshapes terrain in real time. Ryan Park, Juno co-investigator, leads the study. Tidal forces don't always create global magma oceans. Implications for Enceladus, implications for Europa, implications for exoplanets, implications for super-Earths. Estimated surface age, tens of millions of years, maybe younger. Mountains rise through compression, some taller than Everest, not volcanic peaks. Tectonic uplift from constant resurfacing. The crust buckles under pressure. August 28th, 1789. William Herschel discovers it, little known until Voyager flybys. 1980, 1981. Close inspection begins. 200 kilograms per second total output. Visual confirmation of cryovolcanism, cold volcanism, water acting like molten rock. Subsurface ocean confirmed. Global, beneath ice shell. Tidal heating powers the system. Enceladus orbits Saturn every 33 hours. Orbital resonance with Dione, 2-to-1 ratio. Dione completes 1 orbit. Enceladus completes 2. Gravitational tugs, varying tidal forces. Ice shell flexes. Heat generates. Ocean stays liquid. Allows liquid water at lower temperatures. Less energy needed for eruptions. 4.7 gigawatts heat flux observed. Enough to power cryovolcanism without ammonia. But ammonia helps. Composition analysis. Water vapor, molecular hydrogen, carbon dioxide, methane, complex hydrocarbons, organic molecules, sodium chloride, signs of hydrothermal activity, ocean floor vents possible. Farthest from Saturn. Plumes 4 times brighter. Periapsis. Closest to Saturn. Plumes dimmer. Fractures under compression at periapsis. Pushed shut. Fractures under tension at apoapsis. Pulled open. Tidal pumping. Edwin Kite, University of Chicago, models the mechanism. Vertical slots. Surface to ocean. Water level rises. Water level falls. Saturn's tidal stresses drive the cycle. turbulent dissipation and fractures, sustained eruptions explained, astrobiology target, future missions proposed, Enceladus life finder concepts, direct plume sampling, search for biosignatures. Cassini ended 2017, no successor yet approved, but the data revolutionized outer solar system science. 460 degrees Celsius surface temperature, over 80,000 volcanoes detected, radar mapping, Magellan spacecraft, 92% coverage, 3 cycles, 1990 to 1994, surface 90% basalt, lava plains dominate, volcanic features everywhere. Global resurfacing event hypothesized, or ongoing volcanism. Evidence accumulates slowly, sulfur dioxide variations, upper atmosphere, 1970s to 2000s, concentration changes. Volcanic outgassing suspected, but no direct observation, no confirmed eruption until 2023. NASA Jet Propulsion Laboratory. Announcement. Volcanic activity detected. Using Magellan data, 30-year-old images, manual comparison required. Different viewing geometries, different cycles. Automated processing impossible. Focus on suspected active regions, Tharsis, Atla, and Beta Regio. Northwestern flank. Volcanic vent. Cycle 1, 2.2 square kilometers. Cycle 2, 8 months later, 4 square kilometers. Size doubled, shape irregular, computer simulation, viewing geometry accounted for, physical change confirmed, expanding lava lake or magma drainage, direct detection of active volcanism. Volcanic and tectonic origin. Laurent Montesi, Maryland professor. Quote, "Look, this is not an ancient volcano, but one that is active today, dormant perhaps, but not dead. Clustered distribution, geologic survey instruments, easier positioning, planetary science journal, multiple evidence lines combined, nighttime emissivity data, Venus Express spacecraft, Virtus instrument, high emissivity, unweathered basalt signature. Previously thought, lava flows 2.5 million years old, maybe 250,000 years old. Much faster than previously thought. Alteration rinds form quickly, few years to 10,000 years maximum. Emissivity signatures masked rapidly. Unweathered flows at Eden Mons must be extremely young, 10,000 years, maybe just years. Coinciding with volcanism. Dincheco team combines datasets, spacecraft observations, laboratory studies. Conclusion. Eden Mons recently active, possibly ongoing. Anywhere from 10,000 years ago to just years ago. First combined evidence, recent eruptions, recent tectonic activity. Terrestrial planet other than Earth. Detectable for consecutive Earth days, 2008, 2009. Hot gases or lava. Volcanic eruptions. Scientists suspect 4 potentially active volcanoes. Mott Mons, Oza Mons, Sapis Mons, Eden Mons. Future missions planned, Veritas Orbiter, NASA, Envision Orbiter, European Space Agency, launch 2031, high-resolution surface mapping, detect surface changes, confirm volcanic activity, investigate eruption rates. Phosphine detection, Venus atmosphere, 2020, controversial, possible biosignature, or volcanic origin. Active volcanism could produce phosphine. Understanding volcanoes crucial. Interpreting atmospheric composition, life detection efforts. Venus volcanism, driven by internal heat, radioactive decay, primordial heat, no plate tectonics. Hotspots remain stationary. Lava accumulates, builds enormous shields, low gravity compared to Earth. Weaker erosion, structures grow larger. Young ring system, ring arcs, capture event violence. Ammonia mixture, stable liquid bodies when molten. First found beyond Earth, only icy body with cryolava lakes confirmed. Nitrogen sublimes, pressure builds, erupts through ice. Southern summer during flyby. South Pole receives prolonged sunlight. Model supported by observations. Carbon dioxide geysers. Mars, South Polar Cap, same mechanism. Multiple plumes observed. Mahilani plume, Healy plume. 2022 analysis. Solid greenhouse model questioned. Cryovolcanic model gains support. Carbon monoxide, surface pressure, 1.4 to 1.9 pascals. Extremely thin. Temperature, negative 235 degrees Celsius, surface atmospheric, negative 229 degrees Celsius, average equilibrium. Colder than Pluto. Kasmata, young plains, 0.8 billion years old in places, complex geological history, capture by Neptune, intense tidal heating, orbit circularized, heating decreased, residual ocean possibly remains, radioactive decay, solar heating, keeps interior warm enough, future missions proposed, Triton should be revisited, ocean world, active geology, astrobiology implications, but no approved missions yet. If you're still with me, this is where it gets bigger. Comment your thoughts below. Area 300,000 square kilometers. Size of Poland. Size of Italy. Volume 1 million cubic kilometers, 100 times Mauna Loa, 20 times wider than it is tall. Escarpment surrounds base, cliff up to 8 kilometers tall. Unique among Martian shield volcanoes. Enormous flank landslides suspected. Total elevation change from Amazonas Planitia plains, over 1,000 kilometers northwest, 26 kilometers to summit. Circus tent shape. Pole shifted off center. Observer on Martian surface, cannot view entire profile. Planet curvature, volcano curvature. Obstruct view, observer near summit, unaware of height. Slope extends beyond horizon, 3 kilometers away. Lava flows travel farther. Thin atmosphere, slower cooling, allows greater flow distances. Structure grows, peak pokes above atmosphere, 72,000 feet. Hiking to summit, hiking into space, literally above atmosphere. 115 million years old. Some flows, only 2 million years old. Recent in geological terms, volcano possibly still active. Quiescent, episodic fashion. Last major eruption, 25 million years ago, but younger flows exist. Surface craters, 200 million years old, implies recent activity. Suspected source areas, Shergottites, most abundant Martian meteorites. Naklites study, 2017. Nature communications, meteorites flung from Mars. Asteroid impact, 11 million years ago. Volcanic growth rate, 1,000 times slower than Earth. Martian volcanoes last longer. Volcanic history stretches billions of years. Climate history encoded. Lava composition, atmospheric interaction. Surface changes over time. 2023 study. Earth and planetary science letters. Olympus Mons basal escarpment. Ancient volcanic island hypothesis. Formed in Martian ocean, northern lowlands. Ocean 6 kilometers deep. Lava met water. Steep slopes created. Concave profile. Common in island formation. Julia Morgan. Rice University. Skeptical. Complex formation history. Time varying. Not single ocean event. Discontinuous benches. Lava spreads during growth. No shoreline required. Debate continues. Radiometric dating needed. Sample return mission. Constrained volcanic history. Understand Martian evolution. Tidal heating. Orbital resonance with Io and Ganymede. Surface young. 60 to 90 million years. Linear cracks. Faults. Lineae. Dense web. Active resurfacing. Plate tectonics analog. Possible subduction. Ice blocks sliding. Small scale. Hypothesized formation. Shallow subsurface lakes. Melting. Refreezing. Fractures ice. Creates chaos. 2011 study. Schmidt team. Subsurface water pockets. 2023 study. Cryovolcanic cones identified. Argonel Regio. Western edge. Southern hemisphere. Tentative, not definitive. 20 times Mount Everest height. Interpreted as cryovolcanic. Similar to Enceladus. 2014. Plumes observed again. Same location, not every observation. Episodic nature. Tidal force modeling. Predicts plumes at apogee. Farthest from Jupiter. Tidal stress is lower. Fractures open. Eruptions occur. Interpreted as plume encounter. Supporting evidence. Water vapor eruptions. November 2020. Stanford study. Geophysical research letters. Brine pocket migration. Manennan crater. 18 kilometers wide. Impact crater. Ancient. Tens of millions years. Impact heat. Ice melts. Water pocket forms. Freezing progresses. Brine remains. Higher salinity. Lower freezing point. Pocket migrates. Melts adjacent ice. Salinity increases. Thermal gradients. Cold to warm. Lateral movement. Reaches crater center, becomes stuck. Freezes. Pressure builds. Eruption. Plume over 1 mile high. 1.6 kilometers. Spider-shaped feature. Surface mark. Galileo imaged. Model incorporates. Eruptions possible. Europa Clipper mission. Launch October 2024. Jupiter arrival 2030. Europa imaging system. Mapping. Imaging spectrometer for Europa. Detect non-ice materials, salts, acids, organics. Spatial resolution. 25 meters per pixel. Composition mapping. Distinguish ocean source versus shallow melt. Salinity measurements. Surface temperature. Ice shell thickness. Framework proposed. February 2025. Nature communications. Discriminate water sources. Combined measurements. Future data analysis. But remote observations complement Clipper data. Cassini-Huygens arrives. 2004. Orbits Saturn 13 years. 127 Titan flybys. Radar penetrates atmosphere. Surface mapping. Synthetic aperture radar imaging. Topography data. Visible and infrared mapping spectrometer. OIMs. Composition analysis. Combined datasets. Geology interpreted. Cryovolcanism suspected. Multiple candidate features. Debate intense. Difficult to distinguish. fluvial versus volcanic. Titan has active rivers, methane precipitation, erosion, deposition, surface modified constantly. 70 kilometers diameter, 1.45 kilometers high, plus minus 0.2 kilometers. Twin peak structure, western indentation, 500 to 600 meters deep. Circular pit inside, 400 meters additional depth, adjacent to Satrapatra. Depression, 30 kilometers diameter, 1.7 kilometers deep. Deepest pit found on Titan, Mohini Fluctus. Bright lobate flow, 200 kilometers long minimum. Emerges from Dune Mons, extends northeast, partially covered by dunes, tens of meters thick estimated. Compositionally distinct. VM's data, green and yellow shades, candidate cryovolcanic materials. Surrounding terrain, blue shades, different composition, dune fields. American Geophysical Union meeting, Robert Brown, University of Arizona, Cassini controller, mountain range description, tall enough, produces cloud streamers, Titan Sierras, comparable terrestrial shield volcanoes, but cryovolcanic composition. Interior structure changes, episodic methane outgassing. Tobias team, 2006, atmospheric methane. Replenishment needed, photolysis destroys methane. 50 million years timescale, short compared to solar system age. Source required. Interior release, cryovolcanic eruptions, Dune Mons, Erebor Mons. Examples, possible outgassing sites. Parts of Mohini Fluctus, significantly brighter. Surrounding plains unchanged, potential ongoing activity. Argon-40 presence, Titan atmosphere. Requires volcanic outgassing, radiogenic argon, potassium-40 decay. Interior source, cryovolcanism transports. Other features proposed, Geniza macula, initially dome, later topography. Not consistently elevated, less convincing. Hote regio, flow-like units, possible cryovolcanism. Formation mechanisms, multiple interpretations, fluvial, tectonic, volcanic, data limitations, coverage incomplete, resolution constraints. Methane or volatile powered, near methane lakes, volatile interaction possible, appear relatively fresh, could be forming today. Future missions, high resolution imaging, repeated observations, surface change detection, confirm volcanism, eruption rates, composition analysis. Water, ice plumes, global ocean, astrobiology goldmine, Saturn's gentle tidal pump, Venus, basaltic plains, 80,000 volcanoes. Recent activity confirmed. Interior heat without plates, Triton, nitrogen geysers, captured wanderer, 8-kilometer plumes, solid greenhouse or cryovolcanic. Mars, Olympus Mons, 22-kilometer Titan, billion-year accumulation, shield that dwarfs Earth, Europa, subsurface eruptions. Brine pockets migrate. Ice, shell dynamic. Ocean, world mysteries. Titan, methane world. Dune Mons rises, cryovolcanic candidates, hydrocarbon haze. All volcanism, all extreme, all revealing processes beyond Earth experience. Giant planets, multiple moons, orbital periods locked, mathematical ratios, 2 to 1, 1 to 2, 4 to 1, predictable tugs, varying distances, constant flexing, interior friction, heat generation melting, volcanism, without tidal heating, these moons frozen, dead, impact scarred, ancient surfaces. But tidal forces, keep them young, keep them active, keep them geological laboratories. Hot Jupiters, tidal heating common, orbital resonances frequent, volcanism likely widespread, detection challenging. But understanding our system informs exoplanet science. Enceladus teaches about ocean worlds. Io teaches about tidal extremes. Europa teaches about ice dynamics. Titan teaches about organic chemistry. Each discovery, each measurement, each image builds framework, predicting distant worlds, interpreting observations, searching for life. Future priority, Mars samples, volcanic rocks, dating lava flows, atmospheric evolution, climate history, Venus samples, challenging but crucial. Volcanic composition, recent activity confirmation, Enceladus plume samples, fly-through missions, analyze organics, search biosignatures, Europa Clipper, plume encounters, mass spectrometry, composition analysis, Titan lander, future concept, sample cryovolcanic flows, organic molecule inventory. Each sample, each analysis, ground truth, models tested, hypotheses confirmed or revised. Organic synthesis, prebiotic molecules, potential biosignatures, experiments guide missions. Missions validate experiments, iterative process. Knowledge accumulates. Archives analyzed, new discoveries continue, 2020, 2023, 2025, publications ongoing, decades processing. Understanding deepens. Future missions build on foundation, a Europa Clipper, JUICE, Proposed Enceladus missions, Triton missions, all inherit Cassini knowledge. Not dedicated moon mission, but opportunities seized, instruments adapted, science maximized, volcanic discoveries, magnetic field measurements, atmosphere sampling, each flyby, new data, new insights, mission continues, future encounters planned. Clipper designed, plume encounters, mass spectrometer, dust analyzer, composition measured, salinity determined, organics detected, biosignatures searched, non-invasive, remote, safe, efficient, revolutionary technique. Enriched composition, chlorides concentrated, spatial variations expected, eruptive sequence, gradational changes, surface properties vary, EIS camera, MIZ spectrometer, detect variations, map compositions, infer sources, validate models. Future data awaits. Launch occurred. Cruise underway. Jupiter approach, 2030. Decade ahead, anticipation builds. Insufficient historical coverage, variability unknown, Enceladus measured, tiger stripes, 167 Kelvin, far above ambient, heat concentrated, not global. Europa predicted, tidal dissipation models, awaiting confirmation, Clipper radar, ice penetrating, shell thickness, heat flow inferred, Venus challenging, surface missions, short-lived, heat flow unknown, long-term measurements impossible, current technology. Volcanic prediction, IO mapped, hotspots cataloged, eruption monitoring, telescopes track, brightness changes, thermal emission varies, predictable patterns emerge, orbital position correlation, tidal stress maxima, eruption likelihood, Enceladus similar, apoapsis brightening, periapsis dimming, tidal model confirmed, Europa predictions, apogee plumes, perijovi quiet, awaiting observation, Titan unknown, monitoring needed, repeated flybys. Change detection, volcanic confirmation, mantle plumes, hotspot provinces, Mars Tharsis, massive bulge, 4 giant volcanoes, weight deforms crust, 20-degree shift, polar wander, volcanic loading. When will Venus next erupt? Can Triton still be active? Will Olympus Mons awaken? Each question. Future mission, future discovery, future revelation. NASA JPL announcement, record-breaking eruption, most powerful observed, science evolves, data accumulates, models refine. Volcanic duration, Venus lava plains, radar brightness, weathering state, eruption recency, Titan dune coverage, flow obscuration, volcanic age, activity history, each layer, each deposit, time capsule, planetary evolution. Millions of years, ocean acidification, mass extinctions, Mars volcanoes, atmospheric thickening, past climate warmer, water flowed, valley networks, lake beds, Venus volcanoes, carbon dioxide buildup, runaway greenhouse, surface hellscape, ocean evaporated, hydrogen lost, volcanic forcing, climate driver, planetary evolution, habitability destroyer, volcanic gases identified, sulfur dioxide, carbon dioxide, water vapor, sodium, potassium, volcanic indicators, atmospheric replenishment, not photochemistry, not biology, volcanism, active planet, geological processes, heat flow, tectonic activity, context for life, conditions assessed, habitability evaluated. Brightness surges, new vents, lava flows, decades of data, baseline established, future comparisons, change detection, coordinated campaigns, multiple observatories, global coverage, continuous monitoring, space telescopes supplement, Hubble, Webb, infrared capabilities, Europa plume searches, Titan atmosphere, methane variations, volcanic outgassing, remote sensing, ground truth awaits. 46 years later, record eruption observed, 4 decades, knowledge explosion, technology advancement, mission evolution, understanding transformation, but mysteries persist, nature surprises, extremes discovered, expectations exceeded, solar system diversity beyond imagination, volcanic processes, universal yet unique, common physics, infinite variations. Each volcano isolated, fed by local melt. Tidal stress varies, chamber pressures fluctuate, eruptions triggered, lava reaches surface, sulfur dioxide vents, plumes shoot skyward, 300 kilometers. Material orbits Jupiter, neutral cloud, plasma torus, Volcano, feeds Jupiter magnetosphere, planetary connection. Water beneath, global ocean, kilometers deep, tidal heating, keeps liquid. Ammonia antifreeze, lowers freezing point, pressure builds, fractures open. Apoapsis alignment, tidal tension, water erupts, 200 kilograms per second. Ice crystals form, sodium chloride detected. Organic molecules present, hydrothermal indicators, ocean chemistry, sampled from space. No drilling needed. 2.2 square kilometers, cycle 1 complete. 1998, cycle 2 images, same vent, 4 square kilometers, 8 months elapsed, size doubled, shape changed, computer models run, viewing geometry corrected, physical change confirmed, lava lake expanded, or magma drained, collapse occurred, either way. Active volcanism, direct observation, 30-year archive, discovery delayed, manual search required, patient analysis. Reward delivered, Venus erupts. Venus warns of runaway greenhouse. Triton demonstrates capture violence. Mars displays geological patience. Europa hides dynamic ice. Titan presents organic laboratory. Together they inform planetary formation, solar system evolution, habitability conditions, life's requirements, detection strategies. International efforts, shared resources, common goals, understanding universe, finding life, protecting Earth, inspiring humanity. Surface reshapes, world evolves. Pressure must release, volcanism ensures both. Jupiter permits no peace. Enceladus, 4.7 gigawatts. Small moon. Massive output. Earth geothermal. 44.2 terawatts. 4,400 gigawatts. Entire planet. Enceladus 500 kilometers diameter. 22 times smaller than Earth. Volume, 10,000 times less. Yet concentrated heat. Tiger stripes glow. Southern hemisphere dominates. Regional focus, not global spread. Efficiency maximized. 1,000 degrees Celsius plus. Basaltic melt, Earth comparable. Hawaiian volcanoes similar. Enceladus plumes, negative 173 degrees Celsius. Water barely liquid. Venus surface, 460 degrees. Hot enough melt lead, lava hotter still. 700 degrees minimum. Triton surface, negative 235 degrees. Nitrogen frozen solid. Plumes defy logic. Cold erupting. Titan surface. Negative 179 degrees. Methane liquid. Ethane liquid. Water ice solid. Rock hard. Cryolava liquid water. Ammonia mixture. Ice melts, flows. Refreezes. Cycle continues. Ocean chemistry. Life ingredients. Astrobiology target. Venus basalt. Similar Earth, but weathered differently. Atmosphere alters. Surface reactions. Unique products. Triton nitrogen. Methane. Carbon monoxide. Water ice. Organic tholins. Dark particles. Complex mixture. Europa briny water. Salts concentrated. Chlorides. Sulfates. Shallow origin or deep ocean. Future determines. Titan water ice. Ammonia antifreeze. Methane component. Hydrocarbon mix. Organic rich. Prebiotic chemistry. Mars basaltic. Iron rich. Magnesium silicates. Similar Earth, but oxidized. Ancient water interaction. Surface rust. Fracture geometry. Viewing angle. Actually broad sheets. Tiger stripe length. Entire fracture active. Water vapor. Ice particles. Continuous emission. Venus. Effusive flows primarily. Shield construction. Lava lakes. Summit calderas. Explosive potential. Atmospheric pressure. Dampens explosivity, but possible. Ash deposits suggested. Ancient features. Triton. Geyser eruptions. Plume columns. 8 kilometers high. Nitrogen gas. Dust entrained. Seasonal control. Solar heating. Peak summer eruption. Europa. Episodic plumes. Not continuous. Tidal control. Orbital position. Apogee favored. Pressure release. Fracture opening. Titan. Unknown eruption style. Evidence indirect. Flows observed. Summit depressions. Caldera-like. But active eruption. Not witnessed. Future confirmation. Energetic particles. Io plasma torus. Deadly environment. Volcanic gases. Sulfur dioxide. Toxic atmosphere. Thin but present. Lava flows. Unpredictable. Surface temperature. Extreme cold. Except near vents. Human exploration. Impractical. Robotic only. Enceladus. Surface. Radiation lower, but still hazardous. Plume material. Ice particles. High velocity. Sand blasting effect. Tiger stripes. Fracture danger. Crevasses deep. Ice unstable. Temperature gradient. Surface negative 198. Fractures warmer. Equipment damage. Venus surface. Impossible currently. Pressure 90 atmospheres. Temperature 460 Celsius. Sulfuric acid clouds. Corrosive atmosphere. Electronics fail. Hours maximum. Pressure vessel needed. Heat management. Extreme challenge. Triton surface. Extreme cold. Negative 235. Nitrogen plumes. Unpredictable. Dark streaks. Surface altered. Methane precipitation. Organic compounds. Unknown hazards. Europa surface. Radiation intense. Jupiter magnetosphere. Shielding essential. Ice crevasses. Lineae dangerous. Chaos terrain. Unstable blocks. Subsurface water. Breakthrough risk. Titan surface. Methane lakes. Liquid hydrocarbons. Flammable. Oxygen introduced. Explosive potential. cryovolcanos, eruption timing, unknown, cold burns, liquid nitrogen, water ice, contact injury, organic haze, visibility poor, navigation difficult, Mars Olympus Mons, lower gravity, easier ascent, but enormous size, multi-week climb, radiation exposure, cosmic rays, no magnetic field, thin atmosphere, minimal shielding, dust storms, global scale, equipment fouling, solar panel coverage, lava flow tracking, radar imaging, cloud penetration, Venus surface, Titan surface, topography mapping, surface change, flow feature identification, spectrometers, composition analysis, mineral identification, gas detection, plume chemistry, atmospheric sampling, magnetometers, induced fields, ocean detection, plasma interaction, ionospheric measurement, gravity mapping, interior structure, mass distribution, ocean thickness, ice shell depth, seismometers, future deployments, tidal flexing, interior properties, magma movement, eruption prediction, mass spectrometry, molecular identification, isotope ratios, biosignature search, organic complexity. Enceladus mission, plume sampling, relatively easy, lower radiation, longer mission, multiple passes, sample collection, analysis aboard, return optional. Europa Clipper, $4 billion, multiple flybys, radiation tolerance, layered shielding, 49 encounters, 6 years. Jupiter orbit, Titan mission, Dragonfly approved, 3.3 billion, rotorcraft lander, multiple sites, extended surface, sample analysis. Launch 2028, arrive 2034, Venus missions, Veritas, Envision, orbital platforms, radar mapping, high resolution, surface monitoring, change detection, no landers, too expensive, technology limits, Mars missions, ongoing program, multiple rovers, orbital assets, sample caching, future return, volcanic sampling, crater exploration, ancient flows, climate reconstruction. Space agencies collaborate. NASA leads, Europa Clipper, Dragonfly missions, ESA contributes, JUICE, Envision, Bepi Colombo Venus, JAXA partners, Katsuki Venus orbiter, sample return collaboration, Roscosmos reduced, political tensions, budget constraints, future uncertain, China expanding, Mars rovers, Tianwen missions, Venus plans, lunar program, space station, growing capability, India advancing, Mars orbiter, Chandrayaan lunar. Venus orbiter proposed, budget modest, efficiency high, private sector, limited role, deep space challenging, planetary protection, contamination concerns, regulatory complexity, but concepts proposed, sample return, resource utilization, tourism distant. Above atmosphere, unique experience, IO observation, safe distance, orbital platform, viewing ports, real-time eruptions, ultimate volcano watching, Enceladus fly-through, plume passage, water sampling, Titan airship, Doom, Mons overflight, alien landscape, Venus orbit, volcanic monitoring, Triton expedition, ice geysers, captured world. 14 years, Io Volcanois, Europa Ocean, Cassini Saturn, 13 years, Enceladus plumes, Titan revealed, New Horizons, Pluto, active geology, future missions, building legacy, Europa Clipper, Dragonfly, JUICE, Envision, next generation, knowledge accumulates. Mars Olympus Mons, sample collected, Europa ice shell, drilled completely, Titan landers, multiple sites, each mission, each discovery, reshapes understanding, expands possibilities, inspires generations. About planets, about moons, about solar system, about us.